Now in this lecture video, we're going to look at the idea of percentiles of a distribution. So let x be a random variable, and let p be a number that is between 0 and 1. Now a level p percentile of the distribution of the random variable x is any real number, which we'll denote by pi sub p, that satisfies the following two conditions. Number one, the probability that the random variable x is strictly less than pi sub p is less than or equal to the value p, and the probability that the random variable x is less than or equal to pi sub p is greater than or equal to p. Now note that both conditions must hold in order for the definition to be satisfied and for a value to qualify as being a level p percentile of the distribution. Now, a special case of a percentile is the median of a distribution. The median of a distribution is a level 0.5 percentile, or pi sub 0.5. Now, sometimes we'll also call this a 50th percentile, and that's perfectly fine. So what this means is that this value, pi sub p, which again is notation for the median, is such that the probability that x is strictly less than pi sub p is less than or equal to 0.5, and the probability that x is less than or equal to pi sub 0.5 is greater than or equal to 0.5. Now again, in order for a value to qualify as being a median of a distribution, both of these conditions have got to be satisfied. So let's look at an example. This will be example 34. So we're going to flip two fair distinguishable coins, say a quarter and a nickel, and record the up faces. We'll let the random variable x be the number of heads showing. So we've seen this experiment and this random variable defined on the sample space of that experiment before. And so now in this example, what we're going to do is we're going to find the set of all values satisfying the definition of being a median of the distribution. And then after that, we'll find the set of all values satisfying the definition of being a 25th percentile of the distribution. So again, sometimes we'll talk about things like 25th percentiles, 50th percentiles, 95th percentiles, and so forth. Other times we might speak of them as 0.25 level percentiles, 0.5 level percentiles, and 0.95 level percentiles. It's just a matter of scaling. It's going to be equivalent in terms of what we're doing. It's kind of like thinking of a probability first as a proportion, a number between 0 and 1. So for example, we might speak of a probability of 0.05, but then we also might talk about or refer to a probability of that level as being 5%, a 5% probability. So we will speak of these percentile levels in both ways. Now let's first recall that the space of this random variable x, the number of heads showing, is the set of integers 0, 1, and 2. And now to find a median of the distribution, note first that the probability that x is strictly less than 0 is 0, all right, because there are no values in the sample space strictly to the left of 0. And so this probability is equal to 0. Now, this satisfies the first condition because 0 is less than or equal to 0.5. So this first condition that must be satisfied is in fact satisfied. But now we look at the probability that x is less than or equal to 0. This probability is 0.25, but that is not greater than or equal to 0.5. Now remember that both of these conditions have to be satisfied in order for, in this case, 0 to qualify as being a median of the distribution. And so since this second condition is not satisfied, 0 is not a median of the distribution. Now let's consider the value 1 from the sample space. We note first that the probability that x is strictly less than 1 is 0.25, and that is less than or equal to 0.5. So this first condition is in fact satisfied. Next, the probability that x is less than or equal to 1. Now that probability is 0.75, and that is greater than or equal to 0.5, and so both conditions are satisfied. So this implies then that 1 is a median of this distribution. Now let's consider 2. Is 2 a median of this distribution? Well, we first look at the first condition. All right, is the probability that x is strictly less than 2, is that less than or equal to 0.5? Well, no, because the probability that x is strictly less than 2 is 0.75, and that is not less than or equal to 0.5. And so therefore, since the value 2 does not satisfy the first condition, 2 is not a median of the distribution. All right, now let's look at finding a 25th percentile of the distribution. Now let's again first consider 0 as a candidate. So the probability that x is strictly less than 0 is 0, and that is less than or equal to 0.25, and so the first condition is satisfied. We next look at the probability that x is less than or equal to 0, and that is equal to 0.25, and that is greater than or equal to 0.25. So because both of these conditions are satisfied, by definition, 0 is a 25th percentile of this distribution. Now let's consider the value 1. We note first that the probability that x is strictly less than 1 is 0.25, and that is less than or equal to 0.25. Next, we consider the probability that x is less than or equal to 1. That probability is equal to 0.75, and that is greater than or equal to 0.75. So both conditions are satisfied, and therefore, by definition then, 1 is also a 25th percentile of the distribution. So we found that 0 is a 25th percentile of this distribution, and also 1 is a 25th percentile of this distribution. What about 1/2? What if we were to consider 1/2? Well, we would find that 1/2 does satisfy the definition of being a 25th percentile, so it's a percentile as well. In fact, any number between 0 and 1 inclusive will satisfy the definition of being a 25th percentile of this distribution. And so every real number on this interval from 0 to 1, this closed interval, is a 25th percentile for this distribution. Next, let's finally consider 2 from the sample space. The probability that x is strictly less than 2 is 0.75. That is not less than 0.25, and therefore 2 is not a 25th percentile of the distribution. So just in summary, the answer to the first part, find the set of all values satisfying the definition of being a median of the distribution. Well, that set is the singleton 1. 1 is the only median of this distribution. For the second part, find the set of all values satisfying the definition of being a 25th percentile of the distribution of x. And we found that every real number on the interval from 0 to 1, the closed interval, which means that both endpoints are included in the interval that we're talking about. So all real numbers greater than or equal to 0 and less than or equal to 1 are or qualify as being a 25th percentile of the distribution of x. All right, now let's look at example 35. Roll 2 distinguishable fair dice and record the up faces. Let the random variable x be the sum of the two up faces. So we've seen this example before. We've seen the experiment. We've seen the random variable. And so in this example, we're asked to find the set of all values satisfying the definition of being a median of the distribution. And also, as in the previous example, find the set of all values satisfying the definition of being a 25th percentile of the distribution of x. Now, there are too many values in the sample space to run through each of them, at least on the lecture video. All right, if we were doing this in person or just doing it on our own, we could do that. But I'm going to, for the purposes of cutting down the amount of time that we have to spend on this, I'm going to start with 7. And so note that the probability that x is strictly less than 7 is 0.417, and that is, in fact, less than or equal to 0.5. So this first condition is satisfied. The probability that x is less than or equal to 7, which is 0.583, is greater than or equal to 0.5. So both conditions are satisfied in order for 7 to be a median. And so by definition, 7 is in fact a median of this distribution. Now here is a graphical illustration of what we're talking about here. So this is the CDF. You'll remember this is the CDF for the distribution of x in this particular scenario. And I've drawn a horizontal red dotted line at 0.5, which is the level of the percentile that we're looking for. And then I've drawn a vertical red dotted line at the location of the median that we found. And so you get a visual idea of what we mean when we are talking about a particular percentile, and in particular, in this case, a median, what that, let me see here, let's go back to it. So what that graph looks like. So what we're looking for graphically is the point or a set of points at which the CDF pops up over the particular level of the percentile we're looking for. Either pops up above or is right at that level. And so in this case, because the CDF is below 0.5 for all values of x less than 7, and yet once we get to 7, all right, right there, we see that the CDF is at least 0.5. That would indicate to us that 7 is the median of this distribution. Okay, now let's find a 25th percentile. And so note first that the probability that x is strictly less than 5 is 0.167, and that is in fact less than or equal to 0.25. And then the probability that x is less than or equal to 5 is 0.278, and that is greater than or equal to 0.25. And so both conditions are satisfied in order for the value 5 to be a 25th percentile. And so by definition then, 5 is in fact a 25th percentile of this distribution. Now here's a similar kind of graph. Again, this is the CDF for x. And in this case, I've drawn a horizontal line at a probability level here of 0.25. And so you can see here that the value that we found, 5, that satisfies the definition of being a 25th percentile, is the value at which the CDF attains or exceeds the level, which is 0.25. All right, so to summarize the results of this example, so find the set of all values satisfying the definition of being a median for this distribution. Well, it's the singleton 7, so 7 is the only median for this distribution. And then likewise, find the set of all values satisfying the definition of being a 25th percentile. Well, the only value that satisfies, the only real number that satisfies the definition is 5. All right, now let's look at example 36. Roll a fair die and a weighted die and record the up faces. the weighted die is constructed in such a way that the probability that the die lands with a given face upwards is proportional to the number of pips or dots on that face. Let the random variable x be the sum of the two up faces. So we've seen this example. We found the PMF and the CDF for this random variable x. Again, what we're asked to do is to find the set of all values that satisfy the definition of being a median of this distribution, as well as finding the set of all values that satisfy the definition of being a 25th percentile of the distribution. So note that the probability that x is strictly less than 8 is equal to 0.4444, and that is less than or equal to 0.5. The probability that x is less than or equal to 8, less than or equal to 8, so we're looking at that same value, that is 0.6032, and that is in fact greater than or equal to 0.5. Because both of these conditions are satisfied, the real number 8 is by definition a median of this distribution. Okay, and we can see here by this graphic that where I've again drawn a horizontal line at 0.5, and we can see here that 8 is in fact the value, the place, the point at which this CDF either attains or exceeds that level of 0.5. So 8 is the median for this distribution, and in fact it's the only median for this distribution. Next, note that the probability that x is strictly less than 6 is 0.1587. That is less than or equal to 0.25. In addition, the probability that x is less than or equal to that same value 6 is 0.2778, and that is in fact greater than or equal to 0.25. So again, by definition, in this case, the value 6 is a 25th percentile of this distribution. And so here again, with this graph, I've drawn a horizontal line here at 0.25, and we see here that the vertical line that I've drawn here at 6, where it intersects this, so we see here that this 25th percentile, 6, that's the point, again, at which the CDF attains or exceeds that specified level of, in this case, of 0.25. And so 6 is the 25th percentile. And so again, to wrap this up, to summarize, so to find the set of all values satisfying the definition of being a median of this distribution, okay, there's only one value. The median in this case is unique, and its value is 8. For the second point, find the set of all values satisfying the definition of being a 25th percentile. And so here we have, there's only one 25th percentile. That value is 6. Okay, so we've seen the definition of percentiles, level P percentiles. We have seen a specific example of a particular type of percentile that has a special name at least, and that's the median of a distribution. And we've also seen how to find another particular level of percentile, for example, a 25th percentile. We could just as easily have found a 75th percentile or a 90th percentile, or whatever is of interest or applicable in a given situation. But we see how we have to go about doing it, at least in the case or in the context of discrete distributions. You'll notice that every example that we looked at here was a distribution for a discrete random variable. Now, in the next lecture video, we'll see how to find percentiles of continuous or distributions of continuous random variables. But I just want to point out here that in this lecture video, all of the examples dealt with distributions of discrete random variables and finding percentiles for those distributions. To do that, we had to make sure that two conditions were satisfied. If either one of those conditions is not satisfied, then the particular real number in question does not satisfy the definition of being a level p percentile.